Welcome engineers, my name is Travis IQ, and today we're talking about network management, specifically SNMP, the Simple Network Management Protocol. We're going to use it in the context of aggregating data, pulling information off of boxes with things like SNMP GET requests, as well as making configuration changes with things like SNMP SET requests. Let's talk about the fundamentals, set a little network up, and make some changes. Let's go. So before we jump into some basic SNMP configs, and I mean basic, setting up SNMP server configs as well as maybe making some set and get requests, right, in Packet Tracer, let's start with the fundamentals of the Simple Network Management Protocol. So what it's used for, why we use it, what it looks like in our organization. And so the first thing is, what is it, right? And how does it work fundamentally? And so what it is it's used to either make configuration changes with something like SNMP SET packets, or to get information off of the boxes with things like SNMP GET requests. And so these are some of the SNMP packet types: SET, GET, and the third common type that you may be familiar with, you might be thinking about it here if you've done anything with SNMP and are looking for a little bit more information, is traps. And so sets, right, set variables, gets, request variables, and traps are notifications. So you may think to yourself, Travis, if I'm aggregating a bunch of data on these boxes and I'm requesting that information, well, there's probably something I'm looking for, or maybe there's a threshold that I'm trying not to hit, for example, for throughput or bandwidth or maybe MTU changes or something like this. And there are, and oftentimes if I hit those thresholds when I'm not polling, I actually want the box to generate a notification. And by box, I mean anything: router, switch, PC, server, whatever it is that's running my SNMP software, my endpoint software. And so the traps are actually these notifications. So you might have heard this terminology. I received an SNMP trap and it wasn't great, something happened, an interface was flapping, or an interface shut down, or a device is reset, these types of things. So these are the types of packets and the type of information that I could get from SNMP. So then the next question is, how does it work, right? So what are some, let's say, device purposes in SNMP? And so what we have is, we have SNMP agents, SNMP agents. And so this is software running on the endpoint. Software running on the endpoint. Or intermediate device. But it's a device that's actually aggregating SNMP data, right? Aggregating data to be polled. It's called SNMP polling, when you send out a GET request and say, hey, do you have information about uptime? That's a poll request. It's called SNMP polling, aggregating data to be polled. Then we have network management stations. Management stations. You see these as NMS. Or sometimes they'll just call them SNMP managers. And these are the polling devices. These are the devices that pull all that data and then make inferences or put the data in a database, right? This is the data that's being this is aggregating data on the endpoint. This is where the data is aggregated to. So network management stations, SNMP agents. There's a couple of other really important terms here that you may have heard, or if you've read through these things or haven't, and we're presenting them for the first time, these are critical pieces of information. So one of them is SNMP MIBs. This is a management information base. And I like to think of this as a basis for managing the information. What does that mean, a basis for managing the information? A database? for example, right? So they're called MIBs, but they're basically MIB databases. They're infrastructures to hold the data in, and these have a hierarchy, or they're hierarchical. And so what that means is you can go down and you can drill down into the database. What a hierarchy means, right, is we can go from the top, let's say from the system parameters, down to the interface parameters, down to specific interface parameters on that interface, MTU, uptime, number of packets forwarded, right, these types of things. And so that's hierarchy, right, system, interface, MTU, something like that. And then within that hierarchy, that MIB hierarchy, we have specific object identifiers. OIDs. These are called object IDs. Object IDs are used in all kinds of things, IDs, in all kinds of places in computing, and they look similar, in my opinion, in a lot of computing environments. But in this case, they look like this: 1.3.1.6.4.18.2.11.4, something like this. This is just a sample OID off the top of my head. I'm not reading it off ID. These things, literally, I just came up with these numbers. But that's what it is, and that's what it looks like. And so remember, if I said something like the hierarchy, right? So this is not the correct nomenclature for each one of these numbers, but system, interface, sub-interface information, right? And so that's the hierarchy of those. That hierarchy that I was defining, the OID actually defines that hierarchy and allows the SNMP agent to pull that information and send it back to the network management station. And we'll see this in the config setup. You'll see the OIDs as they are written out, and then you will see what variable type is stored in that OID, an octet or a double or something like this, and then how it's reported back to the management station. And so these are some of the fundamental terms. The management information base is the database that this information is stored in. The OIDs are how we identify those objects within the database. And so if we were to look at how this would actually look in the real world, right, I've got a network management station out here, some PC, some administrator PC, let's say, and it's connecting through the network, through a switch, and we'll actually see this exact setup in the packet tracer setup, to a router. And R1 is running an SNMP agent. And R1 is aggregating data like CPU percentage utilization, right? Like CPU temp, like system ID, like interface statistics, and then there would be some sub-interface statistic information there. This is the type of data that we can get off of these endpoints, right? And so now we think, what can we do with this data? So we could actually pull this box and pull, let's say, CPU percentage utilization off of this router, CPU percent util. And we could actually look at it. We could graph it over time. So we could say CPU over time. And I could generate this graph on the administrator PC. And there are some other utilities out there. SolarWinds has these built-in SNMP polling agents. There's like MIB Manager and some free utilities out there that will actually do this. They have an SNMP Manager built in, and then they also have a GUI that will output that data in a usable format for you, something that you, not usable from a computational perspective, but usable from a visual perspective, right? So that I'll put it in a visual format that you can actually use and garner information for. And so if we had CPU percentage utilization and it was going from 0 to 100%, right? 100% would be the CPU's pinned all the time, and we see that it's at 20% or so for if this is time on the month scale in months, and we see that it's at 20% if we look at an average for a long period of time, and then at some point in the year you see it jump up and trend up. Maybe you don't have a threshold for CPU percentage, but you do know that this isn't good. And so you can start aggregating this data instead of having to go out there and say, and get out here, right, if we're a small environment, we're not doing any SNMP polling, we're not doing some regular regular network auditing. Instead of getting out here when we get to 90% and saying, hey, R1 is slow, we can go out and say, we can actually look at this over time, and before we get here, we can say, hey, we're trending to high utilization. What is the problem here? We could identify this as a malicious event. So you can see sometimes that often that SNMP information is used for blue teaming, defense, understanding what's going on in your environment, when network changes are made, when VLANs are updated, when CPUs are being pinned, when RAM utilization is high, even though you don't see a lot of running processes in the process IDs in a Microsoft box, right? These might be indicators of malicious events, but you can also see them from a network management perspective in terms of maintaining uptime, in terms of us as network engineers as well. So I would say it's a fundamental component of blue teaming and baselining and understanding your infrastructure, as well as a fundamental component of how we manage network infrastructures. So this might also not just be malicious, but it could possibly instead be just a function of growth. And so as this network grows, that subnet on the left side of R1 here is growing. We've got more users, we've got more data, we've got more developers, and R1 is being overburdened. It was originally over provisioned, right? Which means that we spec'd it much higher than it needed to be so that we could grow. But now we see that the percentage utilization is growing, and we don't have redundancy at this single point of failure, for example. And so now I can go back with real data over the course of months to my management team and say, hey, we need to re-provision this infrastructure for this reason. So it helps us from a technical perspective as network engineers. It also helps us from a blue team perspective in terms of defense and understanding our network infrastructure as well. And so SNMP has a whole bunch of really cool functions. Now, that being said, we've given some fundamentals, we've talked about some cool functionality. I will point out before we move on, if we're talking about malicious components here, if we're talking about the security of our infrastructure, you will always see, almost always on, let's say, things like certification exams, for example, that the simple question of SNMP version 1 versus SNMP version 3. And so obviously there have been updates to the SNMP protocol over the years, where SNMP was originally RFC'd, back in the early 90s, late 80s. There are obviously going to be updates, and version 2 wasn't a great update, so we usually say version 1 to version 3. Version 3 allows for security, so encrypted sessions, username, password, and other user-specific information in terms of access to data and things like this, with what's known as user-based security modules, and I'll go into some of the advanced stuff some other time. And SNMP basically has no security. There are what are known as community strings. If you don't include community strings, which are clear text authentication with it's basically similar to a wireless environment or something like that, where you have a pre-shared key, right? It's basically that, except for without any encryption at all, called a community string. And so we usually consider this basically no security because the community string is passed in clear text, and it's the same for everyone accessing that box. It's very easy to figure out very quickly, if not almost immediately. So these are some of the primary components of SNMP, and we'll go into some of the more detailed nitty-gritty at some other point. What I'd like to do is I'd like to hop into the configs. So the first thing that we need to do is pull in a PC and pull in a switch. So we pull in a 2960 switch, and then finally pull in a router, which is going to be our SNMP agent. The router we pull in is a 2911. Then we need to configure the cables, and we're just configuring this from scratch just to show that we can set up a simple network from scratch and configure SNMP pretty simply. We pull in the straight through cables, and you'll notice that the connection between the router and the switch, or basically the router interface, is shut off as we pull this diagram up into a larger space so that we can see it a little bit better. We notice that the little red triangles are indicating that the router interface is shut off. The next thing we do is enter the CLI and make some CLI changes. So we enter global config, we change the host name to something a little bit more intuitive, SNMP R1_R1, for example. We then configure the SNMP server. So we add the SNMP server command with the RO option, which is the read-only community string. So this starts the SNMP server. We then add the community string for read-write as well. So for write, so we can read, send GET requests, and we can also send sets with the read-write command set. So both the server will both accept GET and sets. We now need to turn the interface on, obviously, to allow us to communicate with the router. So we enter the interface G00 subconfig, and we add an IP address. The IP address is 192.168.1.1, kind of your standard default gateway IP address. And the subnet mask is a /24. And then we issue the no-shut command to turn the interface off. You'll notice when we go back to the diagram that all of the lights are green. We then go into the PC subconfig and add the IP address for the PC, which is 192.168.1.10. The subnet mask is automatically brought in as /24, and then we configure the default gateway. The default gateway here isn't really going to matter because we're not going to send traffic to any remote networks. However, it's probably best practice to configure a default gateway. You'll also notice that there's a MIB manager built into the desktop GUI for Cisco's Packet Tracer. So we click on the MIB manager, and then we enter the address of the managed device, the agent, which is 192.168.1.1, and then we have to add the community strings. So the community strings are R1 and then R1RW from our previous configuration on the router. And so these community strings are going to be passed to the router to basically authenticate, although this is no security because we're running SNMP version 1. I navigate into the MIB tree, and these MIB trees are just standard MIB trees that are kind of built into the defaults in the Cisco Packet Tracer. You could add MIB trees for custom devices if you wanted to. I don't think that there's an option for that in here, but in any regular SNMP manager there is. You'll notice that I send an SNMP GET request for system name, and the system name is SNMP_R1, and it's returned as an octet string, and you can actually see the OID specifically associated with that sysname OID as well. We can then navigate around the tree. We can look for things like system description, for example, and pull the system description. If I had pulled that value tab out a little bit longer, we could actually get a little bit more information about the system description. If I wanted to do something like get bulk, I can't do that because get bulk isn't supported in SNMP version 1. But what I can do is I can do sets. And so what I'm going to do here is try and set the SNMP system name to something different other than what we had originally set. So some new _SNMP is going to be the host name. But it actually didn't accept that. You'll notice it says bad value. Why doesn't it accept this set request? We can actually think about it. If we go back, when I pull the set up again, it's going to show that it's being set as a bit value and not as an octet value, right? So it's actually trying to set it with the wrong value type, and it's not going to accept it. And so what we do is we actually go back to the set, and when we pull the set back up, we actually change the data type to an octet string, which will be accepted. And when we set that new value, you can see that it's reported in the results table as new _SNMP, but we really need to go confirm this. And if we actually look in the CLI, we can see now that the host name has actually been changed on that device, new _SNMP. And so we can pull other information, things like interface types and interface statistics, and some of this data is stored in tables and tabulated data, and there are other storage mechanisms in SNMP, but I think that's pretty sufficient for this discussion to this point. So, as is always the case, I hope you learned something about SNMP. If you like the video, like and subscribe, and as is always the case, engineer, break stuff, have fun, and we'll see you next time.